Welcome everybody. As Greg mentioned, my name is Derek, and I am currently talking to you from Perth in Western Australia, where it's just past 11 p.m. and I am doing this via a mobile hotspot because I'm at work and the network didn't allow this broadcast through. So hopefully it's all coming through nicely. My background is I usually introduce myself with the words, my name's Derek, I'm a developer. I've been doing it for many decades. With the last, I would say 10 years, I've been doing front-end and mobile development, building startups, helping enterprises, and building cool stuff on mobile devices. This talk I'm going to give you today, there is quite a bit of code, so probably half of it is me coding. It is 11 p.m. so it's not live coding. I recorded all of this code this morning. It is an application I built specifically for this talk in the series of blogs that Greg mentioned. So without any further ado, let's just get into it. So we're talking about, and the slant I'm going to take for this talk is offline first development. So when we talk about building mobile applications in an offline first manner or an offline first paradigm, we always think about a number of things and complexities that we have to deal with when we're doing that. So the first one is all about the data. So our data model and the data for our app needs to be available so our users can use the application when it's disconnected. That's key. The second is whenever that new data and that device becomes connected again and new data is either pushed to the back end or comes in from the back end, we need to code into our application, and most times in the back end of our application, some way of detecting conflicts and a way of resolving those conflicts. And then finally, well, how do we then manage the complexity as the device comes online, offline, synchronizing that data and doing all of that. And traditionally, we wrote code. We wrote lots and lots of code because they're complex problems, and to solve complex problems, you need complex code. So that is the traditional approach. But what if I could talk to you today about ways that we can actually abstract away that connection state and that managing that connection state, so you don't have to think about it, or we could abstract away also the conflict detection and resolution, so that rather than as a developer having to think about having to have it as a backlog item in a sprint, is actually already working for us. And also, if we could have the option of, instead of building boilerplate code and thinking what that boilerplate code is to scaffold out our app, what if that code is available that we can just pull into our application and get it running? So the mantra being that if that's all done, then that leaves a lot of time for us to build out the real features that our application requires and the features that we need to make our application stand out and be outstanding in a very competitive market. It is 11. So I'm going to start with introducing you to Amplify. This is going to be a one-slide introduction. Amplify is AWS Amplify is a way for the full stack developers can build out web and mobile applications. So it enables developers to configure backends, but also allows us to connect to those backends and to interact with them with ease. And we do that by using a number of tools inside the Amplify toolkit. We use the CLI, we'll use the admin UI, we'll use both of those tonight, as well as Third, open source components and libraries that are all on GitHub. And so we can pull those libraries in to our application and reuse those components. Now, those components comprise a number of different feature categories, we call them. They're all here. Tonight, I'm going to be talking about Flutter. And the Flutter categories that are currently supported by Amplify are in orange there. So the Flutter categories, Flutter has been supported by Amplify for, it went GA this year. It came out in beta last year. So it's still early days for the adoption of the Amplify and Flutter libraries, but I'll show you how well they do actually work. And I'm going to do that by building an application. And what application am I going to build? So I'm going to build for you the humble shopping list. So we've all been there. We've been to the shops. We need to know what we're going to buy. We write a note and we tick them off as we go. Now, if we are in a share house or there's a number of people who contribute to the shopping, then it'd be really nice to share a shopping list. So this is what we're going to build. So there'll be a number of screens. We'll start off with the display list, which then transitions via a floating action button into a modal that'll pop up and it'll go into your groceries. And then once you enter your groceries, you'll get the modal will disappear, it'll pop, and then you'll get a list which you can then tick off as you go through your shopping. If you'd prefer the TLDR of this, this code is available on my GitHub repo. But otherwise, let's start coding. So this is where you might want to start and make the screen bigger, because I'm going to show you, first of all, how simple this UI is by building it out, by composing the widgets in the screen. So here we have our main.dart and our shopping app. So the first thing in the state I want to do is just make it nice and green, because green is my color. I'm from Ireland. And then we have a home screen called the shopping list view, which has a number of widgets. Obviously, it has a state because it's a stateful widget, so we define that. Once we've defined the state, in the build method, we've got an override, a nav bar, and a floating action button. So the nav bar is simply just the title. Floating action button is the action that brings up that dialog. So let's define our nav bar. Very simple text, my shopping list, nothing to see here. After that, that's floating action button. So the floating action button simply on pressed event brings out a new widget, which is the new item view. And then define that widget. The new item view is simply a title, a dialog, and a button. The on-pressed event for that button is currently empty because we haven't wired up any action yet for that. But that's the UI. In essence, that's the shopping list UI. So if we build and deploy that, you notice I'm using VS Code because I really like the developer experience in VS Code. Not apologizing. I think it's really nice. So once the binaries are generated, we'll push it to, I've got a pixel 4 there on the right. So there is my UI. See my widget tree looks reasonable with my app bar, floating action button, etc., etc. Just test my floating action button. Boom, should then pop up the modal. There it is, and I should be able to enter text, which I can. Cheese is the first thing I always put in my shopping list. But as you see, when I hit the button, nothing happens. It's just a UI, a dumb UI, let's say, with no actual actions yet. So that's the first part of my app. It's the UI, nothing startling. So with the UI built, I'm building this application with an offline first paradigm. So I need to define the data model. So the data model needs to define and needs to work with the device disconnected. So to do that, I'm going to use a feature category from Amplify called data store. So data store enables me to do a number of things, but it really enables me to address the complexities of an offline first application. I don't know if you know. What it does is provide a simple API that I can do fill operations on my data to. It will persist that data via that API into the local data store itself, so SQLite, and you don't need to be connected to anything for it to work. So the first stage in building that out is to define the data model. So I do this in the Amplify sandbox. So this is the part of Amplify you don't need an AWS account for at all. You can get started now if you want. Just jump in, you pick a feature, you test it locally, and then deploy that feature. So I'm going to do a data feature. I'm going to start from a blank schema, and I'm going to build out a data model. So I name, so shopping list items is item table is my container table. Then inside that, I'll have a number of fields. Every shopping list item needs a name, so I'll have a name, and I'll make it required, because you can't have a shopping list item without a name. And it has that Boolean is complete or is purchased that I'll define as a Boolean. Now, as well as that model, later on in the demo, I'm also going to do a profile stream. So every user has a profile on my application. So I'm going to define that model as well. And I can do that now up front because I'm comfortable with what I see a user profile is. It's just a username, which is a string. It's a the next thing I need is an email address, obviously. The other one is an image, so I want to display an image for my user, and then some description about my user. So again, these two independent models, if I had lists between them, I could define them as well. But for this demo, I'm just going to two independent models. So here, this is where it steps through. So I can choose my platform. So I can do Android, or I can do cross-platform. Today I'm doing Flutter, so I'm doing cross-platform. I hit next, and then steps me through the steps that I need to add into my project that I've started to install Amplify. So here is all the steps. So I can copy and paste these steps into my project. So the first one is install the Amplify CLI, then defining the dependencies in public.yaml, adding the minor min SDK versions in build and Gradle, and then all of this boilerplate code, the scaffolds out and configures Amplify. It's all provided for me. So it's a case of just copying and pasting it, and of course cleaning it up, because clean code matters inside your application. So this is what I'm going to do now. So the first thing I need to do is do an Amplify pull. That uses the Amplify CLI to pull down my data model that I just defined in the sandbox. So why do I do that? Well, it generates the models and types for me in Dart. So once that's successfully done, I then need to go into my public.yaml, add in the two lines that I've just been told to do in the website, which is the dependencies for data store and for Amplify Flutter. Tidy that up because my copy and pasting skills are not the best in the world. Save that you then. Yes, sorry.
I'm just going to interrupt for 1 second. We've got quite a bit of problems with the audio. It's very warbly and garbled coming through. I'm not sure that there's a lot you can be able to do about it, but I know that I've had people refresh their browsers, but it's coming through quite garbled right now. So
okay.
Just to make you aware, I'm not sure how much you can change there, but it's
that is. If I refresh my browser, it's probably worth a go if it's that bad. Okay, so Greg's coming through nicely. Hold on. Let me also.
Yeah, refreshing your browser might kick you back out, but you can always join back on the stage again.
Let's see from my mic. So I'll go direct to my mic and see if that works. Is that a little bit better?
It's still quite garbled.
There. Okay, so I will refresh my browser and see if that fixes it. If you can bring me back in, Greg.
Yep, sure thing, no problem.
Okay.
All right. Apologize for the delay, everybody. On that, we'll try to get Derek back in the room here pretty quick and hopefully get that audio. My suspicion is that it's probably the mobile hotspot upload speed is not quite what it needs to be. So we'll see if we can get that going again.
Okay. Apologies. Is that any better?
Yes, it does appear to be better. Thanks, Derek.
Yep. Okay. Let's get back into it. Of course, no, my sharing isn't working. Okay, let's see if I can fix that. I can start that up again. Right. So,
yeah, you might just want to get full screen on the slide deck.
Yep.
In presentation mode, but other than that, I think hopefully we'll keep our fingers crossed that it's working in the audio. So we're good to go.
Okay. So I pulled down the config. So that will then generate my models. Please jump in if the because I can't see anything else apart from my screen. If the sound's bad again. So here I am inputting my dependencies in public.yaml. So we've been here before, and I will just talk through this again. Just the Amplify dependencies that I'm putting in here. Save that, and then it will do a pub get and pull those down. The next bit I need to do once that's finished is update my build.gradle file and set the minimum version. If you remember, these are all the steps that basically are on the website in the sandbox that's told me to do. So I'm just simply following them step by step, just to make sure that they're all done and that the integration with Amplify and Data Store is seamless. So I save that. My next step is into main.dart and do all the imports. Oh, I probably forgot to see the models. So let's look at the models. So here are the models that have been pulled down. So these have been generated from the model that I created in the website. So user and shopping list, the types already defined for me. So that's saved me a bunch of time. Into main.dart, there's a few things I need to do. So I need to create that initialize amplify function method that was described to me. So I'm going back over to my website, copying that method, and then I'm going to paste it in to main.dart, the configure amplify method. And then I'm going to fix up my import statements like so, tidy them up a bit, and then go down to my state, and I need to init state. So let's add the init state override, which I'll do here. And the init state override is simply going to call configure amplify. Again, all of this code is to my left. I'm pulling in super init state configure amplify. So the other thing I need to do, I need to have a boolean that just stores the current state of the amplify configure process. and I set that once I get a successful Amplify configured, i.e. I don't hit any exceptions along the way. So that's Amplify configured. The next, and this is just a little refresher, and this is the steps I went through. So I went through all of those steps, copied and pasted the code across. So the next stage is to define my CRUD operations. So as you can see, both my models are there, plus all of the code that I need to define for the CRUD operations. So create, read, update, delete, and query, all there. And so what I'm going to do next is I'm going to start defining what a create would look like. I'm going to do this inside a repository. So I'm going to define and build out a repository pattern. And I'm going to do it for the create action. So the first thing I do is I'm defining my repository shopping list item repository.dart. It's just going to be a very simple class. And inside this class, we're going to have our get list items. We're going to have our update list items. And we're also going to have an observer on list items. So the reason I'm doing a repository pattern is because of the reason that we use repository patterns is to abstract away the detail of how you are pushing information into your backend data store. Now, this is key if you're building offline first apps, because you want to abstract this away. Because whether you're connected or disconnected, you do not want to know about that when you're saving data. It should all come through your repository. So here I'm just filling out those files, those methods, create, update, and observe. So the create list items, I'm going to just go back into my sandbox here, copy that code from the create operation back into VS Code and paste it in. So obviously this is it's a guide. So it's showing me what I need. So obviously the item name needs to be passed into this method. So let's just fix that up now. Get rid of that, put in an argument that'll be passed into create list items. It'll be a string. If you remember, item name is a string. So I'm now defining that. Next, I need to then change the is complete, because if I'm creating a new list item, I don't want it to be complete. I want to set it to false. Other things I need to do in the create list items, because the amplify data store.save is the wait, so I need to make this in the sync method. So I'll do that. I then need to do the imports. So I need to import shopping list item from the libmodels folder, because remember these were pulled down and generated classes types for us, and also the Amplify library that we added earlier. So that's the create list items. So if I save that, that should format and it should look nice. Oh, obviously I forgot to try catch, because nothing ever works first time, and try catch will enable me to easily debug what's going on. So that's the try catch done as well. And I can do the same for get list items, update list items, and observe list items, just by going to the code here, copying it across, and put it into my repository methods inside my repository pattern. So the next stage in building out how this offline first data is going to look is I need a way of abstracting from my repository pattern into my UI. So I'm going to use a pattern called block. So Flutter developers out there probably come across it. I give this talk to other non-Flutter developers, and I love the block pattern. I love when I've been abstracting away UI elements from actually persistence and how to map those events. Reactive is the way to go. So block is the reactive implementation for Flutter. So I'm building out my block. So which is a business logic component, and a qubit is like I don't want to say it's block for dummies, but it's because I'm using it, of course. But it's a simplified version of block that acts on events rather than streams. So you can actually mutate the block from components. So here I am defining my item list qubit, and inside my item list qubit, I need to define a repository. So I've just done that. I have not imported the block dependency, so I'm doing that in publishback.yaml. Now, after I've done that, let's just fix that up. I then need a constructor. Yep. So I build out the constructor. I then need to map the actions that I've got in my repository to my block. So I define my git list items, my update list items, my observe list items inside my block. And that's what I'm doing now. So this is a simple proxy back through into my repo. So the list items, first pass in the item name, and that will create me a list item. Same for update list, but I'm not going to code all of these. I'm just demonstrating how I'd build out my persistence layer if I was coding an offline first application. So one that's special is this observe items. So what observe items is going to do, it's going to listen on the event stream. So and it's going to listen for changes on list items. So what it's going to do is for the type, I didn't describe this well, of the type of shopping list item, any event that occurs on that item, one of those types, it will invoke get list items. So what it's doing is, I've registered a change in shopping list items, get all of the item lists. So what that's going to really help with if we have incoming data changes. So the last thing we need to do to implement the block pattern is we need to define inside the UI the block provider, and then pass in state and the type. So this is all I'm doing here is defining that it's like the final step. So repository into block into UI. As this is main dot, this is the first screen that we'll see. And it will get all of the list items, and it will also test the observer. The child itself, so I'm going to change this based on the Amplify configure state. So if his Amplify is configured, show the shopping list view. Otherwise, if it's not configured, you probably want a loading screen or something to hold the user until Amplify gets configured. So that's what that's doing there. So that's cool. So that is I've defined my data model. I pulled it down locally, and I've started to build out how I would implement persisting that data in a local first manner. So if you haven't come across the block pattern before in your Flutter developer, I'd recommend it. I like it a lot. So here's just a quick overview. Started at the bottom with my repository, into my block, and then into my UI, so that then I can decouple the UI from my implementation of how I store data. So the next part in the puzzle is how to test this locally. So making sure all the code changes I have made work in a local deployment, so not connected to a backend or anything. And then once I'm happy with that, the next stage of this development process is all about building that backend. So let's test what we've built so far. So here I'm back in shopping list item view. I'm in the on pressed event inside the elevated button. So before that didn't do anything. Now it calls create list item, and it passes in whatever I've typed into the item name controller. And I've also implemented a small widget that gives me an empty list view. So once I first start up the app and I've got no shopping list items, it will display the empty list view. So that's what we should see when we first start up the app. Get rid of that, and there we go. So your shopping list is empty. So let's floating action button, get that modal up, pop in a probably cheese again, add the shopping list, and this time it actually populates. So what happened now? I've got my data model. It's persisting locally. I'm happy with the flow of the screens, and I'm ready now to go to the next phase, which is deploying what I've built into AWS. So I hit the deploy to AWS button. This will then give me the option of create a new account or use an existing account. I'm going to use an existing account and deploy everything that I've built so far into AWS. So what have I built so far? So to all intents and purposes, I've built a data model, but I've built a lot more than that. Using the data store component, I have also built out the CloudFormation scripts or the templates that allow me to provision AWS AppSync, which is the GraphQL managed GraphQL service at AWS, and Amazon DynamoDB, which is our NoSQL object store. And those services are going to be used then to synchronize the data between clients. I didn't write any code to do any of that synchronization. It's all part of data store. So here I am now deploying those changes across, and what it's doing, it's provisioning AWS AppSync, and it's provisioning a new table in Amazon DynamoDB. So once that's done, I can then, once it's been deployed, I then pull down that configuration back into my local development environment. So that was that Amplify pull does. So it will then ask me a few questions like, what's my IDE? What am I using? Where's all my source files? And this enables me, and do I want to modify this backend? So this enables me to do two things. I can modify the backend using the Amplify CLI here in my local development environment, or I can also use the Amplify admin UI, which is the UI I've been using to modify that backend environment and then pull that configuration down. So it gives me a lot of flexibilities about how I want to develop this app. So once it's pulled down, what have we done? So we've built our local first persistence mechanism inside our application. We've then provisioned a backend infrastructure. So that's enabled what's called the sync engine to come online. And the sync engine runs on the device. And what the sync engine does, it communicates with the resources that Amplify is provisioned in the cloud. That's Amazon DynamoDB and AWS AppSync. So the sync engine will observe any data changes that have happened inside my app. It will then translate those into queries and mutations inside GraphQL, which will then store it on Dynamo. And then what AWS AppSync will also do is generate subscriptions on those queries and mutations, which will push any changes back down to the device and synchronize my data, which is pretty cool because I didn't write any code for that. And also, it will also allow me to implement custom conflict and detection resolution algorithms. So by default, we get an auto merge. So the auto merge is quite, it'll always prefer server side. It will concatenate lists, so you will get duplicates. In sets, it will union a map. It'll traverse the map and apply rules like the sets and the list rules above. You can also define optimistic concurrency, which is basically if a version mismatch comes along. So if the server version and an update version are incorrect, then it will always prefer the server version. And you can also write your own Lambda resolution, so resolvers. So what that does is you can choose your own adventure, how you want to handle conflict detection, how you want to handle conflict resolution, which gives you a lot of flexibility. So let's see how this then works. So I've got an app here, I've got an empty list, but because I've now deployed to the back end, I can go to admin UI and I can start adding data into my DynamoDB table. So if you think about it, this is my backend store for my application. So this is a great way of testing if that synchronization mechanism is working. So inside my data, you can see that I've got my models that I defined earlier. They've all been copied up. And I have this content tab that I can start adding test data into. So I create a shopping list item. As I say, always have cheese at the start. Save shopping lists, and you can see it's synchronized right away to the device. I can add another one. Crackers goes well with cheese. Add that in, again, synchronized nicely. I can then change test to mutations on the is complete. So I can change that and save that. And that works nicely too. So that's really nice. But once I'm happy with that, I can then start to think about, well, I could probably test this with two devices. So let's stop that simulator and start a new one, a different type one, a different emulator. So I've got another Android emulator over here somewhere. So I can grab that and make that the destination for deployment. So let's do that, select it, F5. And then we can test device-device communication. So what we've done is we've gone through the flow of building out a data model, testing it locally, deploying it. So we've got a backend persistence mechanism, and then we can just test that out. So we've tested it out from a backend going down to devices, and now we're going to test it from end to end, so device to device. So once they both come up, let's just add some more test data here. So cheese, crackers, and some milk to wash them down, and that is synchronized nicely. We can then say, oh, I've shopped and I bought the milk, and it's synchronized across devices, and then the other device can say, no, you didn't, and deselect that. So that's synchronizing nicely. Everything seems to be working, and I didn't write a lot of code to get that work to work. So that's the data store feature, and that's how you can negate some of the complexities of building offline first applications. But what about other stuff? So there is other stuff that you can do with Amplify, and I'm quickly going to touch on one of them, and that's all about image upload. And I'm going to use that inside my profile page. So I've got my profile page. I can select an image, so to change my avatar, and once I've changed it, that will display on my profile page. So this again uses Amplify. It uses tools and that we've been using before, but this time we're using for each category. I'm also going to quickly touch on the analytics category, which uses Amazon Pinpoint in the background. So let's quickly, I'm just going to go through the code for this. I'm not going to actually code it. I'm going to take you through the steps, and you'll see that no matter what category you implement with Amplify, they are definitely a pattern that you can reproduce to do every category as you add them. So here, I'm showing you the profile view. So you do the UI first, app bar, profile page. App bar's nothing in it. Profile page is an avatar, title, email. It looks a bit like this if I go over to my device, and that's my UI. Then once you're happy with your UI, the next bit is to add in the category that you need. So you add it to the configure amplify method. So amplify storage is the category we want to use to store images. We then add it to our pubspec.yaml. Again, amplify storage. Now, storage, as the name suggests, persists all of the images in S3. Once we've done all of the UI and pulled in the dependencies, the next thing is to implement our repository pattern. So again, like we did for data, we need a storage repository, and the storage repository I'm implemented is very simple. It's got an upload file, so amplify storage to upload file, which it'll push that file up, and then I've also got a storage repository method that'll pull down the URL for the file. So that way, people can log on to different devices and pull down their profile image accordingly. So if we look at it working, we click on the avatar, click on a new image, so from Guinness to Guinness, and then that comes across nicely, and that's our new profile picture. So that's how that works. And it's exactly the same for analytics. So I add in, if I wanted to do analytics, and I've added in analytics to this app, I add in the dependencies, I add it in and pull in dependencies, and then where I want an analytics to happen, I can just code it in. So this is Amplify showing me what I've got installed in Amplify. So I've got all of those categories installed, and these are all the endpoints for them. And then I can also, so once I've got all of this functionality into my app, I can go to the single pane of glass, which is the Amplify Admin UI, and I can actually dive into the implementation of this backend. So for storage, for images, I can actually dive into the S3 bucket where my images are if I want to. And so these are all the images for the app. So for profiles. Likewise, if I want to look at the GraphQL API that data store is using, I can jump into that. So the only time you want to do stuff like that is just to glory in the amount of code you didn't have to write. So that's all of the schema that had been generated for me. And then you can also dive into the underlying data store. So Amazon DynamoDB, and just took a look at the data that's been persisted. You also see table type names, TTLs, updated at. So this is all used by the synchronization mechanism. And then you can also look at my profile table as well and see all the profiles I've got. So once you can have a look at those, and then finally you can have a look at the analytics. So I've got analytics installed. It's tracking anytime somebody adds a shopping list item. So you can deploy analytics, view it via the Amplify Admin UI. So everything's there, one place, so you can have a look at it. And as well, I've showed you the content before, so this is just the content. And then finally, I've also employed auth and auth to this app. So this is the authorized user that I've added to this application. So that is in a very quick overview, and I apologize about the sound, about how to build out an app, Flutter app on Android using Amplify. I have the code there. I also Amplify Flutter libraries themselves are open source, so you can get them in Flutter, be part of the community, and contribute. There's also a series of blogs that I've written that go into some detail about some bits of this and more detail in others. So have a look at that. Thanks for listening. I apologize that the sound came out. I hope it didn't affect the presentation too much, but yeah, I believe, time for Q&A. Thanks.
Thanks, Derek. Yeah, I think we caught the sound issue early enough. Looks like we have one question that came in right now, and if you flip over to your Q&A, you should be able to see that in there, and we'll see if anything else comes in the meantime after that. Okay.
Yep. That's a good question. So you can definitely set up Amplify for different environments. So what I did there, I had Sandbox. So that was an environment that I've just used for Sandbox. There's an Amplify CLI command to create different environments. So you can go, I think it's Amplify env, it's the command. And what that does, that changes the configuration file that you're using. So you can switch between environments. So you can go Amplify env dev, and then you can work with dev, you can push dev, and work with that backend, or you can go Amplify sandbox and interact with that environment. So you can definitely do that. It's just I was using default, which is sandbox. Great question. So the updates are coming through WebSockets. So if your device is backgrounded and has killed the WebSocket connections, you may not get updates. You would have to test that depending on how brutal your parse saving is being. So, we've all built mobile devices. It depends on the device. It depends on the operating system. But yeah, you would have the same problem for any WebSocket implementation app that you had, if that makes sense. Yes, absolutely. Great question. So with AWS, and this is a strategy that you should always adopt, is having alarms. So there's very detailed cost explorer in AWS, and you can set an alarm if your account or a particular service goes over a threshold. Now, in saying that, all the services that I show today, apart from Pinpoint, I think, are on the AWS free tier. So you can quite happily build a development environment in them, and you'll have a negligible impact into your AWS account. But in saying that, never go into beyond dev, or indeed any long-running AWS account without at least a catch-all alarm on your account spend, because then you can just deal with it rather than dealing with the build, which is like a 60-day alarm, which you really don't need. Yep. So I set the min SDK version. I think they were both. I can't remember. I haven't got my ID open. Yeah. So what I was doing there, I was just follow the instructions that come from the admin UI. So I didn't notice that when I was doing it today, actually. I haven't dived too deeply into it to see the discrepancy because it worked. But you could be onto something. Yeah.